This video will be a follow along to get some practice on multiple choice questions regarding slope fields. This is for AB Calculus, AB, and BC. I just took these questions from some PDF that some few teachers posted. Okay, I just did a simple Google search and I thought these were good practice problems. Okay, so most people struggle with these types of multiple choice questions because these are simple follow a procedure, follow an algorithm type of problem. Okay. You actually have to do some reasoning. You have to do some critical thinking as to why a slope field doesn't work for a differential equation and why a slope field does. So you have to be able to understand why some cases don't work and only one of the cases that is given the multiple choice does. You have to be able to think it through yourself. And it's not a simple, straightforward way every single time. It's very different depending on the slope field and the equation. All that to say, hopefully, if you're just totally lost as to how to approach these, how to think these problems, maybe you can watch how I approach it and then you can mimic it. Okay, of course, you need to get your own practice in to really master it. But if you're totally lost, hopefully, how I'm thinking through it, so I'm basically going to be talking out loud or thinking out loud. I'm already talking out loud. I'm going to be thinking out loud, sharing my thought process on how to eliminate choices and all that. Okay, this is multiple choice. So lots of time for these, at least for me, I just do process of elimination. Okay, but some general tips first of all. Okay, this is just from me doing so many problems and helping students with so many problems. These are general things that I found are good things to look out for to maybe eliminate choices right away, or even pick the choice right away. So you want to find when the slope is 0. Okay, that's when the line that's drawn as the slope is flat. Okay, those are easy to spot, and hopefully those are easy to eliminate choices as well. I'll go into more specific examples of all of these when we go through the problem set. There's 14 of them. I don't know if I said that already. And similarly, we can look at when the slope is undefined. Those are also quite easy to spot. And we see if there's a pattern, and maybe we can eliminate choices from that. Okay, another one is the slope unchanging along some line? So for example, if you see that the slope as you move across the x-axis for a fixed value of y, so let's, for example, pick y equals 1. If you sweep along the x-axis and the slope is not changing, then you have an idea that the differential equation dy dx shouldn't depend on x, because as you're moving through x, the slope's unchanging. Okay. Similarly, if you're moving vertically and the slope is unchanging, the differential equation probably doesn't depend on y. Okay. And another special case is if it's unchanging across a linear line, for example, y equals x, that's a special case as well. That can help us eliminate choices as well. We'll see that one in a bit, actually. Okay. And after you exhausted all this honestly, most of the time you can eliminate maybe 2 or 3 choices already, a lot of time. Once you exhausted this, then you have to start checking for relationships between the signs of x, y, and the derivative dy dx. So I'll go over what that means in the problem. So these are best to be learned by looking at actual examples and problems, okay? So this is a follow along type of video. So I'm going to ask you to try the problem first yourself when it appears on screen and unpause it to see how I think through it. So you might be totally lost for this first one, but what you do, at least try something first, okay? So this first one says, which of the following is the slope field for the differential equation dy dx equals x over y? So which one is it of the 5 choices here? Hopefully you can see it on screen and it's not too small. Or you can probably find this problem set online. I just Googled different or slope field multiple choice practice problems and I found this. Okay. So let's look at equation first. Remember, for my general tips, it's helpful to know when the slope is 0 and when the slope is undefined, okay? So when is the slope, which is dy dx, 0 here? It's 1, x equals 0, okay? Of course, y cannot be 0, but in general, it's mostly when x is 0, okay? So where is x equals 0? That's the y-axis. So we expect flat lines at the y-axis. This one clearly doesn't have that. Eliminate choice A. Same for this. We see the slopes right there, right? It should be flat. So cross out B. This is flat everywhere on the y-axis. Good. This is flat everywhere on the y-axis. Good. This is also flat everywhere on the y-axis. Again, hopefully you can see this. Okay, so we eliminated A and B already. See, we eliminated two choices just by that one tip. Okay. Now, how about undefined? That's when y equals 0. So on the x-axis, so it doesn't look like they have a slope on the x-axis. So we're out of that tip. Now, is there an unchanging slope as we move across the x? No. How about the y? No, it's changing, right? So, and we know that because this has a dependency on both x and y. So we knew that right away. So that's what I meant on this third guy over here. So now we're at the last point. We need to check the relationship between, so maybe I should say relationship between the signs of x, y, and dy dx, okay? So let's go back to here now. Okay, so for example, when we're in quadrant 1, this is not in the text, so I'm explaining my thought process out loud. This is what I probably would have done first. When we're in quadrant 1, or either 1 or 3, usually I go first. When we're in quadrant 1, both x and y are positive, okay? So when both x and y are positive, dy dx is also positive. So this is fine. The slopes are always positive. This is fine, but this is not fine. So we actually eliminate choice D by that, okay? I didn't say that in the text because I chose quadrant 3 first, but if we chose quadrant 1 first, hopefully that made sense, okay? Now let's check quadrant 3. If both x and y, quadrant 3 is when both x and y are both negative. So if they're both negative, then dy dx has to be positive as well. Here, it's positive, right? Here it's positive, and here it's negative. So we're eliminating choice D by checking quadrant 1, but that's what I said in this text over here, okay? So that's one way to approach that. And now we're left with C and E, right? So now what do we do? Okay, so let's look what's happening. So let's like pick a value of x. Like let's pick x is 5 over here, okay? As y increases, what's happening to the slope? Look at those lines, it's getting steeper, right? The slope is getting bigger. Similarly, over here, as y is decreasing or getting more negative, it's getting more and more steep as well. Okay? Does that relationship make sense for this equation? As y gets bigger, shouldn't the slope get smaller? Actually, dy dx should get smaller if y gets bigger. So that doesn't follow this relationship here. We cross out C, and our answer is E. But let's double check. As y increases, it gets less steep, which we expect because y is getting bigger, the denominator is getting bigger, dy dx is getting smaller. So that's happening here. And similarly, we go downward, same trend. It should get less and less steep. Okay, so you can see how you have to think these through. And some of those tips actually help, especially we're looking for when the slope is undefined or when the slope is 0. We eliminated two choices already. I guess here, I picked slope is undefined. Oh, I did explain that, if I remember correctly. I really don't remember what I explained. Okay, so hopefully this is helpful to see how I think through it. And if you were totally lost, okay? Now, let's go to problem 2 and try another one. Which differential equation has the slope field shown? Go ahead and try this one. Okay, so do we see any patterns? Hopefully you do. Like here, when x is 0, the slope seems to always be 0, no matter the y value. So this is when I was talking about this third one over here, okay? You see that the slope isn't changing as we move along in the y direction, okay? So that can help us sometimes. It might not help us here because I'm looking at the choices. It might not help us here, but I'm pointing that out to explain what that was. That can help us eliminate choices, okay? But anyway, So before I even go to my text, let me just do this live again. Let's eliminate some choices. I can already eliminate choice B because the slope should always be positive. X squared is positive, y squared is positive, so dy dx is always positive. But look, over here, we have some negative slopes. Cross out B. That's one example. Okay? Similarly, for this is again doing this last one over here, relationship between the signs, okay? In quadrant 3, both x and y are negative. Down here, this is quadrant 3. So we would expect dy dx to always be positive. But look, there's negative slopes. We cross out A. Okay, so we crossed out A and B already. So we're left with C, D, and E. Okay? So what do we do now? We can do similar analysis, okay? So let's look at, okay, I'm trying to do this live again. So this might be a longer video. Okay. Let's maybe take this quadrant as an example, okay? We're going to do the relationship between signs at increase, decrease again, okay? So here, let's pick x is -3, okay? As y increases, what's happening to the slope? It looks like it's getting less steep, okay? So actually, now see, I'm trying to think out loud right now. In this quadrant, x is negative, right? But y is positive. Okay, so let's keep that in mind. X is negative in this quadrant, but y is positive in this quadrant, okay? So we're left with CDE, right? If x is negative, negative cubed is negative, but y is positive, so dy dx should be negative, okay? That's correct, it seems like. And that's correct here. This one won't make sense though, okay? Because, again, x is negative in this quadrant. So again, for example, pick x is -3. So -3 squared would be positive. Y is positive. We're above the x-axis, right? So the dy dx should be positive in quadrant 3 for this equation, but we have negative slopes here. So we eliminate D, okay? So now we're left with C and E. Which one is it now? Okay, so maybe picking quadrants. Would this quadrant help? Let's see. If both x and y are negative, then it's negative divided by negative. So dy dx should be positive, but we have negative slopes there. So we eliminate C, the answer should be E. Okay, let's see if that's what I did. The answer is E, okay? So as I said in the beginning, right? B requires all slopes to be positive because x squared is positive, y squared is positive, so dy dx is positive, okay? So it should be positive everywhere, so we eliminate B, okay? What did I say here? In quadrant 4, where x is positive and y is negative, the slope is always positive, okay? It is right here, okay? So we can eliminate A, C, and D. So I picked a different quadrant as I just redid it again now, but let's explain this one. X is positive, y is negative. So that means for this one, the slope should be negative, but we have all positive slopes. Okay, cross that out. C, x is positive, y is negative. We should have a negative slope. These are all positive, cross that out. See, this is what I'm talking about, relationship between the signs, okay? Similarly, x is positive, y is negative. This should be negative slope, but again, it's all positive slope here. So cross that out, answer is E. Okay. So here's a more efficient way to think about it. All right, but as you saw, as I did it live, I was picking different quadrants and checking the signs and all that. All right, number 3, the slope field of a differential equation is shown. Which of the following could be a specific solution to that differential equation? So this is now asking what the function is, not what the derivative is. So this is asking it a little differently. Or it's asking something different in general. So go ahead and try this one first on your own. Okay, so if you got totally lost, how do we approach these? You don't want to take derivatives of these and start matching. Okay, you don't want to do that. The solution should fit into these slope fields. It should match the shape of these slope fields. The slope field is describing the rate of change of the function. Okay, so that's why the function should fit inside. So let's even see. Or you can take my word for it first. Which function does this look like of these over here? It's clearly not natural log because natural log is undefined when x is negative and when x is 0. So this value's over here, the slope's over here. The derivative doesn't exist though, over there for natural log. Okay? X cubed, it kind of looks like an x cubed, right? So let's keep that. Sine x, nope, clearly it cannot be because it oscillates, right? This doesn't look like it. Cosine x, same thing. 2x squared, a parabola does not match. It matches on maybe here, but not on this side. Okay? So what did I say? Yeah, don't bother taking derivatives. Which curve fits best into the slope fields? And as I said, it looks like the cubic would, okay? And I think this is pretty much all I said as I was solving it live again. But even here, for example, when x is 0, sine x we know is increasing. Okay, remember how the graph of sine of x looks? X is 0, sine x is increasing. However, this is saying that the slope is 0. There's neither increasing nor decreasing. So it's a maximum in there. That's not the case. Okay, that's another way to eliminate y equals sine x. And similarly, cosine x, we know at x is 0, it's at the max of 1. It's going to decrease immediately right afterward. So there should be a negative slope. Okay? Like right afterward, but it's a positive slope here. So nope, that's not the case. And similarly, 2x squared, the parabola, when x is less than 0, isn't the slope of the tangent lines negative, but it's positive over here. So no. Okay. And you can hopefully see, once again see that the x cubed function does kind of fit into here. Okay. Remember the general solution is a fourth x cubed plus c. So this is why this you can shift it up any amount and it will work. That's that plus c is. Hopefully I'm relating the other stuff into here. Okay. So the quickest way for these is usually just seeing which function fits into the slope field. So again, this is asking the function, not the derivative, matching the function, not matching the derivative. So a little different. Okay, number 4. Which function is the solution to the differential equation with the slope field shown? So go ahead and try this one. Okay, if we take what I just said of matching or kind of imagining what function this slope field follows, it looks like the natural log, right? How does e to x look? It looks like growing exponential. So clearly no, the slope should be getting steeper and steeper actually. E to the negative x should have negative slopes. It's an exponentially decaying function. Okay, x squared for sure won't fit this. It's growing fast. This is growing slower and slower actually as x increases. Cosine x should be oscillating. The derivative should also repeat. Remember the derivative, cosine is negative sine. So it should have like waves also, but that's not the case here. So the best answer is choice A. Okay, problem 5. Which differential equation has slope field as shown? Go ahead and try this one first. Okay, so let's go back to the tips real quick. Here is let's apply this. Notice that for that guy, I'll go back in a bit. The slope is unchanging along y equals x. That we can use to our advantage probably to eliminate some choices. Okay? The slope looks like it's the same along this line, probably is y equals x. Okay? Yeah, if we check the check marks, it looks like it is. So what does that mean? Well, we can eliminate choices. I should say that, okay? Because when y equals x, then we get this relationship. When y equals x, the slope is unchanging along this line y equals x. So that's probably B and C. Okay, when x and y are equal, the derivative is a constant number. Doesn't matter what the x and y are, as long as they're the same. Okay, so we can eliminate A, D, and E. So see how looking for patterns helps us eliminate over half the choices already, or pretty much half the choices. It's an odd number here. Okay, So it's B or C. Now, let's look at this particular small region here, is what I decided to do. Okay. In this area, okay, we fixed the value of X. Okay. So as Y increases, what's happening to the slope? It's getting less and less steep. So which one is it? Is it B or is it C? As Y increases, the slope gets less and less steep. That is B. Because as Y gets bigger, dy dx gets smaller. Slope gets not as steep. Cannot talk. Okay. All right. Number 6, which differential equation has slope field as shown? Go ahead and try this one. All right. Notice there is a pattern. It's not at y equals x like the other one. It looks like it's at like, I don't know, y equals x plus 1-ish. So that might help us out. So based on doing the previous problem where the slope was unchanging on the line y equals x, it's not over here. So on this line y equals x is probably something like this. It's changing, actually. Look, it's changing. So we can eliminate b and c here. Okay? So we're left with A, D, and E. Now what do we do? Okay? So for choice A, notice if y is greater than x, the slope is positive. But if y is less than x, the slope is negative. It's not a coincidence that this is the line where they're equal. Okay? Over here is when y is greater than x. And over here is when x is greater than y. Okay? So it's probably A. But let's confirm by eliminating, what was it? D and E, okay? So let's take quadrant 1, okay? Most of the time, we should have positive slope if x is positive and y is positive. Or let's just take x is greater than 1 and y is greater than 1, okay? The slope should always be positive, but you can see it's not. It's somehow negative over here, okay? The only place where a slope can be negative is when, for example, in the quadrant 1 specifically, when x is between 0 and 1, that's when this term would be negative, but y is still positive, right? So that's what makes it negative, when x is between 0 and 1. And similarly for this one, when y is between 0 and 1, the slope could be negative, or is negative, okay? But that's not what's happening. So any value, any x value greater than 1, any y value greater than 1, the slope should be positive, but clearly that's not over here. This is for sure bigger than 1. X and y are bigger than 1, right? So we eliminate D and E, and we can safely say it's A. Okay? 7. Which function is a solution to the differential equation with the slope field shown? Okay, hopefully you tried it. Which function kind of follows this shape? Probably the cubic is what I'm thinking. Okay? For sure not this. Or, okay, maybe here's another trick. Remember, even functions are symmetric about the y-axis. So if you think about it, if this is the slope field of an even function in quadrant 1, then on this other side of the y-axis, we should have the same slope, but except it's negative. Think about that, okay? So we can already eliminate all the even functions because that's not the case here. Again, if this is the slope on quadrant 1, then the slope in quadrant 2 should just be negative of that. Okay? Think about it. And then you can even try for like y equals x squared. Okay? But with that said, we can eliminate the even functions, which are b, e, and c. Those are all even functions. Sine x and this guy, this cubic, is odd. Okay? And clearly the sine x doesn't fit this, so the best answer is D. Okay. Oh, that's exactly what I said over there, the even function stuff. Okay. So that's it in text. Hopefully that can help you as well. Okay, problem 8. The slope field for a certain DE differential equation is shown. Which the following could be a solution to the differential equation with the initial condition y of 0 equals 0? Let's go ahead and try this one first. Okay, so which function matches this or follows this profile? This one's kind of hard to tell. It's not as easy as the other one. Okay, but we can actually eliminate C right away. It says we need the initial condition y of 0 equals 0. So the point 0, 0 should be on these curves. What's y of 0 for this guy? When plug in x is 0, you get e squared. That's clearly not 0. Eliminate C right away. Doesn't even meet the initial condition. All the others would, though. Okay. Now, let's look at the special cases again. For example, we see that it seems to be undefined. The slope is undefined at x is -2. Okay, so actually, D, B, and A all meet that, so that doesn't help us actually. But how about when this guy, if we factor for choice A, if we factor the bottom, we get x plus 2, x minus 2, right? So that means that if choice A were the answer, we would have no slopes on x equals 2 as well. It's also undefined. But look, there's slopes there. So we eliminate choice A. Now we're left with B and D, right? So let's take B now. Well, when is tangent x equals 0? That's when, we know that tangent x is undefined at pi over 2. I think that's what, yeah. Tangent x is undefined at pi over 2. What's pi over 2 approximately equal to in decimal? If we even round pi down to 3, and pi over 2 is about 1.5. Okay, so we expect no slope at around 1.5 because tangent is undefined at pi over 2. Where's 1.5? Oh, there's slopes there. So probably not B, and therefore the best answer is D. So we see how we used when the slope is undefined and when the slope is 0 to our advantage here, mainly undefined. Okay. All right. This is not a multiple choice, but I thought this was a good problem to think about. Explain why the following could not be the slope field for the differential equation dy dt equals -0.3y. So why not? This is actually one of the tips I gave. Okay, so instead of x is t, by the way, doesn't matter though. So this is the t-axis, okay? The slope, the value of the slope does not depend on t. Okay, that means for a fixed y, as you step through the t's, the slope should be unchanging. Think about that. If it doesn't depend on t, as we move, or yeah, let's take when t is 0, the dy dt would be, sorry, t is 0, y is 5, dy dt would be -1.5, right? Now, when t is 1, y is still 5, dy dt is still -1.5. When t is 2, y is 5, dy dt is still -1.5. It doesn't depend on t. So as we step into t, that's why I was saying the slope should not change, but clearly it's changing. So that's why this is not valid. Actually, this is probably modeling dy dt is -0.3t, because as we step in the y direction, it looks like the slope is not changing. So it's not dependent on y. 10a, match the slope field with one of these equations. So which one is the slope field for? So which function follows this behavior? Okay, it looks like there's an asymptote at x equals 0, vertical asymptote. Okay, which one has a vertical asymptote? That's only E and possibly H as well, because we can't have ln of 0. So the natural log looks something like this, if you can see my cursor. It grows, but very slowly, okay? This is decreasing, it looks like. So clearly not H, and therefore it's E. And if you know how this curve looks, it looks like this exactly. Not surprised, actually. Now that I didn't think before I said it out loud. But anyway, that's what I've been saying here. Okay. 10b. How about this one? So it's probably either G or H. This looks like the sine wave, sinusoidal, I should say. So is it sine x or is it cosine x? Okay. Well, when x is 0, the slope is 0. So that means probably a maximum in there. Which one has a maximum in at x is 0? That's cosine. That's G. Okay. And I didn't say this in the previous one. I said this in some of the slides, but notice how if it's cosine x, this guy right there, the slope, it is cosine x plus c. It's giving all possible c's. Okay. How about this one? 10c. We notice that this is the pattern. This is the one tips. The slope is 0 at, what is this? This is x equals 0. So when x is 0, this dy dx should be 0. Okay. Also, remember the thing I said about even functions? This is the profile of an even function. We have slopes of this sort on the positive x side. We take the negative and put it over, reflect it over on, or yeah, we just basically reflect over the y-axis. So this is the even function. Which are the even functions in this list? It's A, C, E, G, and technically H. That's even as well. Okay. Is that what I said? Yeah. A, C, E, G, H. Okay. So of those, which one fits best? Clearly not y equals 1. That's a flat line. Okay. C, parabola. Yeah, it kind of fits the parabola, right? Let's keep that. E, technically we already picked, but clearly no, because it should be asymptote at x equals 0. So no. Cosine, technically we already picked that, but pretend we didn't. It doesn't oscillate and all that. Okay. And technically also we picked H, I think, right? Or maybe we didn't yet. I think it's one of the choices actually. So hopefully I didn't give anything away. But the natural log, even on quadrant 1, it slowly grows, but the slope is getting steeper and steeper actually. So that's opposite of actually what's happening. It's going slower and slower. So it should be getting less and less steep for natural log. Okay. So the best answer is C. Okay, hopefully the even function thing makes sense after you've seen this now. Okay, D, hopefully this one's simple enough. Which one is it? It's A. Y equals 1, horizontal line. 1 plus C. Okay, and we know the slope is always 0 for this guy. We differentiate it, clearly it's 0. Okay. E, what about this one? This looks like an even function profile again. So which ones were they? It was like A, C, E, G, and H, right? Which one of those is it? Well, this one looks like the natural log. So this is what I was thinking earlier. So the best answer is H. Okay, F. How about this one? Which function does this look like? Y equals X, B. Okay, and notice how it's X plus C. Here's when C equals 0. Here's when C equals 1. Here's when C equals 2, so on and so forth. Okay. Problem 11, this is actually from the 1998 AP Calculus exam. The slope field shown is for which differential equation? Okay, so we'll use our tricks from before. This is saying that no matter it doesn't depend on y. There's no dependency on y. Okay? So when you step up or down, the slope should be the same. Clearly, that's not the case. We can eliminate B. And remember, for D, when x is equal to y, then the slope is 1. Okay? Is that the case here when x is equal to y? No, the slope is changing. So we eliminate D as well, okay? And E, similar to B, we can eliminate this because this has no dependency on x. So for a fixed y, as we step in the x, the slope shouldn't change, but it's changing. So which ones do we eliminate? We eliminated B, D, and E. We eliminated over half the choices already. So now there's two more. This one also has no dependency on Y. We already concluded that there should be a dependency, so get rid of A, and the answer is C. We didn't have to do any of the sign tests actually here. Okay, so this is a good problem to use all those tricks, tips, tricks, whatever I call them. Okay. Once you really get those down, then eliminated choices is not too hard. Okay. 12a. Match each slope field with a differential equation. So which one is this one? Okay. We can eliminate C because this should have no dependency on X per the equation. But as we step across the X, there is a dependency. The slope is changing. Eliminate C. Similarly, when X is equal to, when X is equal to Y, the slope should be -1. And it looks like it actually is. And look, at the origin, the slope is undefined, it seems like, or either flat that we can't see it, or it's undefined. But it makes sense that it's undefined because Y, we can't divide by 0 when Y is 0. Y is 0 at the origin, okay? So it's likely actually D, just by that special case again, okay? This has no dependency on Y, so by similar logic again, so like how we did for C, we can eliminate A. And this one, when Y is equal to X, the slope should be 0. So in quadrant 1, when Y equals X, so I think it's only quadrant 1 actually, when Y equals X, actually it should be over here as well. Yeah. So yeah, when Y equals X, the slope should be 0, but that's not the case. So eliminate B as well. So answer is D. Okay. I don't remember what I said here, but you can read it through, but I just explained it out loud again. Okay. So pause the video to read it again, or read it if you want. I'm going to move on. Solved it live. Probably solved it similarly. Okay. How about this one? Same choices. So pretend we didn't have part A, so we still have 4 choices, pretend. Okay. It's good to think these through. Okay. There's actually a kind of clever way to think about this. Okay, I don't remember which slide I put it in, but one way to think about it that's totally different than what I've done so far is if we imagine what curve could fit here, maybe a parabola, is there a differential equation whose solution y equals something, that y equals something, that something is a quadratic? Is there one? This one, choice A. Just integrate both sides. Then y would be x squared plus x plus c. That's a parabola. So it might be A. That's one way to think about it. It actually is A. Okay. If we know the solution, we should know actually, if you're taking this class, AP Calculus, you should know what the solution to this differential equation is. It's the exponential function for choice C. Clearly, this is not exponential function. It's not monotonic. It looks like it's decreasing and increasing, but the exponential function keeps increasing or keeps decreasing, depends on if it's negative exponent, right? So clearly it's not C. And we can use the same logic that x over y, if x is equal to y, then the slope should be -1, but that's not what's happening there, it looks like, because we have positive slopes over here. And then this, if you remember from that other problem, or yeah, when x is equal to y, I think I just said this in part A, the slope should be 0, but that's not what's happening. Okay, so choice A is the best answer. Okay, what did I say? Let me actually read this now. So, oh, here's another way to think about it. Okay, look here, the slope is 0 here. This is one of the things I said to look out for, right? The slope is 0 here. What value of x is this? Looks like if we count the tick mark, this x is -2. So which one gives that? And it's no matter the value of y, the slope is the same. So we can also from there eliminate a lot of choices because there should be no dependency on y. This has a dependency on y, this does, so choice is A as well. Okay? So see how you can think of these differently. I just solved this in 3 different ways already. One is finding out that the slope is 0 at x negative 2, only this one would give it, right? Because these have all dependency on y. And precisely, again, this has no dependency on y. We look vertically, the slopes are all the same. So the only one that has that is A, okay? And here's some more reasoning that Matt has said already, so you can pause the video to read this on your own. I'm going to skip through it in the interest of time, okay? How about part C? Well, here we notice that the slope is 0 along the line y equals x. Which one was that? That was choice B, right? Okay, so that's the quick way to eyeball it. Again, I'm not counting that. Oh, we already chose A and D and B. So 12D will probably be C, but let's think through why it's C actually, okay? There's no dependency on X. As we step through the X, the slope doesn't change. Which one has that? That's only C. Okay. Also, that was my second point here, but also look at y equals 0. The slope is either undefined or it's 0, and we just can't see it marked. Okay, so we can already eliminate A and B. So it's either C or D, and then by the other point I said, it's choice C. Okay, 2 more problems. 13, which differential equation would produce the slope field below? Ooh, that's absolute values. So do we get intimidated by this? No, we think it through like we did all the other ones. No problem at all. So without me even going to the next slide yet, I can already tell that it's not going to be D or C because of where the absolute value is. We're absolute valuing everything. So the dy dx will always be positive. Same for here. Dy dx is always positive. There's negative dy dx over here. So clearly it's not C or D, okay? For this, can we reason something to eliminate E? Let's see. When y is equal to x, the slope should be 0. Do we have that? Y equals x, the slope should be 0. Doesn't look like it, especially not over here, right? So we could probably eliminate E, okay? So we're left with A or B right now. Okay, so let's do more sign tests or checking the relationship between the positive and negative of x, y, and dy dx, okay? So let's look at here. When x is negative and y is increasing. So when x is negative, y is increasing. The slope is getting less and less steep. Okay? So which one? We eliminate C, D, and E, right? So it's A and B left. So when x is negative, y is increasing, the slope should be getting smaller. How about this one? Is it A? X is negative, y is increasing, the slope is getting smaller. Yes. Okay. X is negative, so it doesn't matter. We're going to absolute value it. Y is getting bigger. Okay. So let's look at B to rule it out as well with that. When x is negative, y is getting bigger. Okay, so notice when x is negative here, it will become a plus x, right? And then y is getting bigger as well. So the slope should be getting more and more positive. Actually, it is. Did I mix it up? See, that's why I'm solving it live. What's the answer, by the way? Or actually, let me not look. Maybe I even wrote it wrong there. Okay, let me solve this live right now. All right. Hopefully this is helping you, me trying to think this through. Okay, as I was saying, let's take this exact same thing here. I think it's actually B now. Maybe I mixed it up in the next slide. Let's see. So if x is fixed to this negative number, y is increasing. Okay, in this equation, it'll be some positive x that's growing plus a fixed value of x because x is negative. So the slope should be getting bigger, but it should be increasing. And it is. It's going from negative to less negative, right? And if we go in the other direction, y is getting more negative. Is the slope getting more negative in this equation as y is, actually, does that work here? When y is getting more and more negative, then this would become a bigger positive number minus a fixed or plus a fixed x. So it's not b, actually. So what am I doing wrong? Or did I think of A incorrectly? So this might have matched there, but then it didn't match over here in quadrant 3. It matched in quadrant 2 for that value of x, but didn't match quadrant 3. Okay, let's go back to A now. So I apologize that if you already figured it out for your own, but if you're stuck, hopefully you see how I'm thinking through it and working it through. Okay, maybe let's pick a different value. Okay, like over here. When x is positive and y is increasing, it matches this guy. Y is increasing. It doesn't match, actually. Does it? Because when y increases, this would get bigger. Doesn't matter. This is fixed. So the slope should be getting more and more positive, but it's getting, actually, it is getting more. Maybe I'm mixing up steep and positive. Okay. Because steep can be in either direction. It is getting more and more positive. Okay. Let's go in the other direction. As this is a fixed x again, as x is getting more, sorry, y is becoming more negative, we are getting more steep. More negative, I should say. Let's start saying steep here. For this problem, at least. We're getting more negative in slope as y is decreasing. Y is decreasing, we're getting more negative. That works here. When y decreases, it becomes positive, back positive. So this is getting more positive, actually. So it's not B, it is A. Okay. See how these can be confusing if you're not able to think these through? Even I just got stuck right now. What did I say here? So I said C and D eliminate because they require positive slope always. Yep, that's why I explained in the beginning. I eliminated those right away. Okay, I said eliminate B because in quadrant three, as x is more negative, the slope should be becoming more positive. Yes. So I looked vertically, but you can also look horizontally. That's why I was saying in here. As we get more and more in the negative x direction, look at equation B. As x gets more negative, our slope should be getting more positive, actually. But look, it's getting more negative, actually. So we eliminate B, eliminate E as well, because this is what I was saying. When y equals x, the slope should be 0, but it's not the case. Okay, so it is A. All right. We solved this one successfully. We thought it through successfully. It took a few minutes. All right, last one, 14. Which differential equation would produce the slope field below? Okay, how do we go about this one? Should I do this one live again? Okay. So for this one, let's take quadrant 1, for example. When as x keeps getting bigger, we would expect our slope to get more negative. Is that the case? As x keeps growing, the slope should be getting more negative? No. Eliminate A. We can eliminate B for the exact same reason. Because this is very similar. Instead of 3x, it's x over 3, but it doesn't matter. Okay. It should still be getting, it'll get more negative slower, but it still should be in the more negative direction, which is not. Okay. Similarly, can we do something similar for C? Or actually, can we do it the exact same thing on? Okay, let me just go one by one. See, this is the problem where I'm trying to be smart about it instead of going sequentially step by step. Sometimes it might backfire if you try to really try to think of a clever way instead of a systematic way. All right, so for C, will it work? As x increases, the slope should be getting more positive, and as y increases, this is all in quadrant 1, the slope should be getting more positive. That seems right. So maybe for this one, as in quadrant one, as y increases, the slope should be getting more negative. Is that the case? Over here, it seems like it is. Okay, so maybe let's keep that for now. Okay, so that didn't help us though. Okay, so we probably have to pick another quadrant. Okay, how about when here, as y is decreasing, the slope is getting more positive as y is decreasing. That's not C. As y decreases, the slope will get more negative. Okay, so we eliminate C. It's either D or E now, if I'm doing it correctly. So which one is it? As y decreases, the slope should be getting more positive. That's not D, it seems like, right? So it's E, it looks like. Yes, it is E. All right, that's probably what I thought through here, or maybe I'll pick different quadrants. So eliminate A and B for quadrant. Yeah, so I said exactly this point. And then here, what did I do for C and D? Because when x equals 0, it looks like dy dx as y increases. Look, as y increases, dy dx is getting more negative. That's only E. All right. All right, so hopefully that was helpful to just to see how I think through these problems. Really, you see, there's no prescribed method to solve these. You got to be able to reason through these. And hopefully, let me show the tips again. These tips can help you eliminate some of the choices from the beginning quickly. Okay, otherwise, you have to start checking for a relationship between the signs and all that, and increase, decrease as you saw how I did it. Okay, at least that's how I think these through. If you have a different approach, feel free to leave it in the comments to help other people out and for me to learn as well, all right? But anyways, hopefully this has helped. Please give this video a like if you found this helpful in any way.